Welcome to Unit 3 on trigonomic functions. Today we're going to talk about right triangle trigonometry. So we're going to talk about what the trig functions are in relationship to a right triangle. And keep in mind that other than the 90-degree angle, the two other angles in all right triangles are considered acute angles. Not because they're cute little angles, acute meaning that they are less than 90 degrees. So let's take a look right away at the trig functions. Now you might recall or remember some of these trig functions. If you don't, you definitely will after hearing me right now. So first and foremost, there are 6 trig functions: sine, cosine, tangent. Now we write sine, S-I-N, or sin, but we don't ever say sin, please, as a pet peeve of mine. Or cos, don't say cos, it's cosine. And then T-A-N, it's not tan, tangent. So we abbreviate it, but we never say those abbreviations. That's just how we write it. So again, it's important that you understand that those are the 3 big trig functions, but we also have 3 more: cosecant, CSC, secant, SEC, and cotangent. Now, before we get too much further, let's first understand a really important concept, is that the input value to all 6 trig functions, right? A function, there's inputs, there are outputs, right? And you should know that, please. So the input, what you plug into any of the 6 trig functions, is an angle. Now, typically, we like to use a Greek letter like theta, alpha, beta, but I don't really care. You can use an X or a W or a Z. I don't care. It doesn't matter what you use to represent that angle as long as you know that it is an angle. I mean, we could even say sine of X, right? Because typically we do use X as an input when we're working with functions. But it doesn't matter what you call it as long as you understand that this input represents an angle. Now, the output, what you get out of a trig function, is a ratio. It's a ratio of the sides of that triangle. So, for example, the output to sine is the ratio of the opposite side divided by the adjacent. Now, that's the opposite of the angle and the adjacent to the angle. So, let's just talk about the sides real quick. I'm assuming everybody knows this, but I really want to make sure. So, you have the right angle. All right triangles have a right angle. The side across from that right angle is always called the hypotenuse. Like, always. Doesn't matter. But what's opposite and what's adjacent technically depends on the angle. So if you're talking about angle theta, then the opposite side would be, the side opposite of it. The adjacent side would be the side that's adjacent or next to it. Now, technically, the hypotenuse is next to it as well, but we've already called that the hypotenuse. But if I were to switch gears and talk about this angle up here, maybe I'll call it W. Now, all of a sudden, the opposite side would be what I was previously calling the adjacent side in terms of the perspective of theta. And the adjacent side would be what we were calling the opposite side from theta's point of view. So you got to be very careful understanding point of view of the angles. But anyway, hopefully you understand that. The ratio that sine outputs is the ratio of the opposite side divided by the hypotenuse. Cosine is the adjacent side divided by the hypotenuse, and tangent is the opposite side divided by the adjacent side. Now, a couple comments here that are really worth noting is that you should know that in any right triangle, the hypotenuse is always the longest side. Always, always, always. Now, the opposite and the adjacent, one could be bigger than the other. Sometimes the opposite's bigger, sometimes the adjacent bigger. But no matter what, the hypotenuse is always bigger than the opposite and the adjacent sides. So sine is limited. The output to sine has to be a number between 0 and 1. Now, first off, it can't be 0 because the only way that sine can be 0 is if the opposite side is 0. But if the opposite side is 0, you don't even have a triangle. But again, because the opposite side length is always going to be less than the hypotenuse side length, the ratio opposite divided by hypotenuse is going to be less than 1, but still greater than 0 because it's got to be a number. And cosine is going to be the same because the adjacent side is likewise always going to be smaller than the hypotenuse. And if you have a fraction and the top is smaller than the bottom, you're less than 1. And then tangent can actually be any number. Tangent has 0 restrictions because, again, the opposite side, the adjacent side, one could be bigger than the other. One could be 3 times, 4 times, 5 times the other. So again, that ratio could actually be anything. But sine and cosine are definitely going to always be less than 1. Now, the other 6 trig functions are the reciprocals. Some people will say inverse. Don't ever say that. They're the reciprocal functions. We call them the reciprocal functions. So cosecant, which is written C-O-S-E-C-A-N-T, but abbreviated SEC. Cosecant is the reciprocal of sine. So it's the hypotenuse divided by the opposite. Now, in this case, since the hypotenuse is always going to be bigger, cosecant is always going to be bigger than 1. Again, because the numerator is bigger than the denominator. Secant, which is written S-E-C-A-N-T, but it's abbreviated S-E-C. Secant is the reciprocal of cosine, since the hypotenuse divided by the adjacent. And then cotangent is the reciprocal of tangent, so it's the adjacent side divided by the hypotenuse. Or, oh my gosh, I'm sorry. The adjacent side divided by the opposite. So I'm not even going to ask you to memorize these. Most kids do, but I'm asking that you at least, make a note card, put this on it. You're allowed to use your notes, so please utilize this information. That way you remember it. Now, there's one more super important thing that you should know about right triangles, and that's Pythagorean's theorem. Now, Pythagorean's theorem has nothing to do with angles. It's all about the side lengths. So we call the hypotenuse C. Again, always across the right angle. And then again, the other two sides are called the legs. You could call it A and B. It doesn't matter who's A. It doesn't matter who's B. You could switch those up, but C has to be the hypotenuse. And we know that A squared plus B squared equals C squared. That is true in all right triangles. It's got to be a right triangle. But again, that's a ratio, or not a ratio. That's a relationship between the sides, again, having nothing to do with the angles. But it is worth noting. But again, the 6 trig functions that really are going to define this entire unit are right here in front of you, and they input an angle in, and then based on that angle, you find these relationships. Now, just be aware, if I decided to do this entire problem from W's perspective, everything would change, because now sine of W would be this side over here, which would actually now be called the opposite, divided by the hypotenuse. Cosine of W, this would now be called the adjacent side. So again, you got to make sure you understand that when you switch angles, you're switching who's opposite and who's adjacent. So please don't forget to do that. All right, let's take a look at an example. I have enough talking about it. Let's actually put all this to use. So here is a right triangle, and I have two sides marked, 6 and 15, and then I have an angle marked W. And what I want you to do is I want you to find sine of W, cosine of W, and tangent of W. Now, sorry about that. Some kids misinterpret what I'm saying, and they think that I'm asking to find W. No, I'm not asking to find W. W is obviously an angle, but I don't even care what angle it is right now, because I'm not asking you to find the angle. I'm asking you to find sine of that angle, which is the relationship of the opposite side divided by the hypotenuse. So again, I'm not asking you to tell me what the angle is. We might do that later on in the unit, but right now I just want to know the relationship of the sides that represents sine of that angle. So the only problem is this. I know two sides. I don't know the third side. So I need to do some work real quick to find that third side. And of course, how do you find the third side of a right triangle? Pythagorean's theorem. Just make sure that the hypotenuse is always on the side by himself. Then I have 6 squared plus, I'll just call it B squared because I don't know what it is. It doesn't matter if you call it A or B. Who cares? But the 15 squared has to go by itself. So now you just got to do a little bit of math on your calculator. 15 squared is 225. 6 squared is 36. Everybody knows that. Subtract the 36. 225 minus 36 is 189. And I get B squared. So now I got to take the square root of each side, and that means that the missing length is the square root of 189. But a couple things here. First, don't get a decimal, because I do not want approximations. You know how much I love exact answers. And the second thing is we should reduce that. So maybe it's lucky, like maybe 89 is a perfect number. Maybe, you never know. Square root of 189, oh, it's not a perfect number. It's like 13.74. So please make sure that you reduce it. I shouldn't have to review this in this video, but I'll quickly go over it. You have to figure out, does it have any perfect factors? So is it divisible by 9? Oh my gosh, I found it right away. Yes, 9 times 21 is the square root is 89. So now I can actually reduce this. So the 9 would come out as a 3. So it'd be 3 times the square root of 21. So always reduce square roots if possible. All right, now I'm ready to go. So sine is, according to W, you got to be very careful. According to W, this is the opposite side. The 6 is the adjacent side. And the 15 is always going to be the hypotenuse. So sine of W would be 3 radical 21 divided by 15. Oh my God, how easy was that? Cosine would be the adjacent side, 6 divided by 15. Oh my gosh, can this get any easier? Seriously? Tangent would be the opposite divided by the adjacent. So 3 radical 21 divided by 6. Now, always reduce if can be, right? We always want the cleanest, beautifulest answers. So, for example, on sine, the 3 goes into 15 5 times, so I can reduce that. I'm sorry, I'm running out of room here. The square root of 21 over 5. 3 goes into 15 5 times. 6 15ths can, of course, be reduced, both divisible by 3, so we get 2 fifths. And then again, the 3 and the 6 could reduce to radical 21 over 2. So always reduce if possible. Now, I could also ask you about the reciprocals. For example, cosecant of w is the reciprocal, which again is the hypotenuse, 15, divided by the opposite side, 3 radical 21. But likewise, you still need to reduce that. The 3 goes to 15 5 times. So that's 5 over the square root of 21. Now, I'm actually totally okay with square roots and denominators. So I would have no problem with this as a final answer. But be careful, because if you're using a computer program, or if you're doing problems from a book, or if you're doing problems on a test, and it does say to not leave square roots and denominators, if it does say to rationalize the denominator, you do need to get rid of that square root in the denominator. And I hope you know how to do that. I shouldn't have to go over it. So again, pretty easy to do. All right, let's take a look at another one real quick. Now, this is a nice one because I gave you all 3 sides, so you don't have to do the Pythagorean theorem to figure out what any of the sides are. But it could be worth you checking that 84 squared plus 13 squared is 85 squared. It is true, but if you want to go and check, you can. But the reason why I want to do this separate problem is because it does matter. Like if I say find sine, cosine, tangent, it matters if I say Q or P. The answers are going to be completely different if you look at the wrong angle. So please read the problem. So let's just say that I want to focus on Q. So what is sine of Q? Now notice, you got to be careful. I'm not asking you to find Q. I'm asking you to find sine of Q. Q is an angle. I have no idea what it is, 21 degrees, 23 degrees. I don't know. I don't care. I want to find sine of Q, which is the relationship of the side opposite, 84, divided by the hypotenuse, 85. Oh my gosh, how awesome is that? Cosine of Q is, again, 13, the adjacent, divided by the hypotenuse. Tangent of Q is the opposite, 84, divided by the adjacent, 13. I mean, this is so easy, guys. I really cannot make this hard. And then again, even if I said, hey, what about secant? Well, you just got to remember, secant of Q is, again, the reciprocal of cosine. So that would be the hypotenuse divided by the adjacent, and so forth. Easy peasy, really, really simple. All right, now the one thing I want to talk about next is really truly making sure you understand inputs and outputs. Actually, let me clean this up a little bit here. That way it looks a little bit prettier. All right, so notice these problems are a little bit different. So here we have sine, and this time I'm not giving you the ratio, right? I don't know what the ratio is, but I'm giving you the angle, 25 degrees. Cosine, again, I know that that equals adjacent divided by hypotenuse, but I know the angle, 78 degrees. You could draw a triangle if you want to, like if it really matters to you. You could, it doesn't have to be accurate. You could just use a picture for simply a picture's sake, and you could say, okay, here's 25 degrees, and sine of 25 degrees would represent the opposite side divided by the hypotenuse. But again, I don't know what those are. But this is where we could certainly use our calculator. So you feel free to use your calculator. Now, there's a couple of things you got to be careful of when you use your calculator. First is that your calculator has a mode. When you use the sine, cosine, and tangent buttons on your calculator, you need to be in the correct mode for what you're typing in. So if I'm going to use degrees, because it says 25 degrees, I need to make sure that my calculator is in degree mode. Now notice that there are 2 different modes for the topics that we previously learned about. The 2 different ways to measure an angle, degrees or radians. So anytime you do use the 3 buttons, sine, cosine, and tangent, please make sure that you know the correct mode that you're in. Because if you're in radian mode and you type in 25 degrees, you are not going to get the correct answer. So because I'm in degrees, I want to type in degree mode. Now I'm going to go back and I'm actually going to type in sine of 25 degrees. So I get 0.4226. Now it is rounded, of course. It is an approximation. So 0.4226. So the input was an angle. The output is a ratio of the opposite side divided by the hypotenuse. Now, what is the opposite side? I don't know. What is the hypotenuse? I don't know. I know that the ratio between them is 4.226. Again, this actually means that I could be talking about any triangle. So think about this for a second, right? Draw a 25-degree angle. And again, I'm not asking you to get a protractor, just understand 25-degree angle, right? Imagine that if I stop right here. If I stop right here and take the opposite divided by the hypotenuse, I would get this ratio, 0.4226, because that's what sine is, opposite divided by hypotenuse. But if I were to make this triangle bigger, notice that the opposite side is now bigger, the hypotenuse is now bigger, but guess what? If I take that opposite side that's bigger, and if I take the hypotenuse which is bigger, I'm still going to get 0.4226. So this is super important to understand, is that the ratio of the opposite divided by the hypotenuse is 0.4226 no matter the size of the triangle. It's all about the angle. So it could be a big triangle, or you know what, it could even be a small triangle. Maybe I make a much smaller triangle, and now the hypotenuse is smaller, the opposite side is smaller, but guess what? When you take the opposite divided by the hypotenuse, you're still going to get that same ratio. All right, let's do this cosine one real quick. We'll spend a little bit less time here, but cosine of 78 degrees is 0.2079. So again, that's the answer, that's the ratio. But again, it doesn't matter what the adjacent and the hypotenuse are, but regardless, when I take the adjacent, I divide by the hypotenuse, I'm going to get 0.2079. Okay, it could be a big triangle, could be a small triangle, doesn't matter. The ratio is 0.2079. Now, I did this next one on purpose because that is in radians. First off, I do not see a degree symbol, so I'm automatically in radians. So I am going to have to go to mode. I am going to have to go back and change myself to radian mode. Now I'm going to type in tangent of pi divided by 3. I cannot tell how many kids get an entire test wrong because they're in the wrong mode. So tangent of pi over 3 is 1.732. 1.732. And again, that's the ratio. So if I were to draw a triangle and label the angle pi over 3, the ratio of the opposite divided by the adjacent side is going to be 1.732. I have no idea what the actual adjacent side and the opposite side are, but I know the ratio of them is 1.732. All right, now, triangles are obviously super important when it comes to trigonometry. So let's talk about two very, very special triangles. And these are the only two special triangles in the entire world, and that is a 45-45-90 triangle and a 30-60-90 triangle. Now, these two triangles are very special because there's a unique relationship between their sides. No other triangle in the world has this unique relationship. Now, all right triangles follow Pythagorean's theorem, a squared plus b squared equals c squared. So that is a unique relationship, but I'm talking about an even extra special unique relationship. So let's look at a 45-degree triangle real quick. So maybe you remember this from geometry, maybe you know. But if you have a 90-degree triangle, that means that your two legs are both the same. So I'm calling them A. So this leg is A, and that automatically means that this leg is also A. And the relationship is that if both of those sides are A, the hypotenuse is A times radical 2. And that is true no matter what. So if this is 5, this is 5, this is 5 radical 2. Always and forever. If this is 7, this is 7, this is 7 radical 2. Easy. Now, if you want a quick proof of this, all you have to do is use Pythagorean's theorem. So if you said, I don't know what the hypotenuse is, a squared plus a squared equals hypotenuse squared. A squared plus a squared is 2a squared equals hypotenuse squared. Take the square root of both sides. And that means the hypotenuse is, again, the square root of 2 is stuck, but the a squared can come out as just a. And there it is. The hypotenuse is a radical 2. So hopefully you understand that. I'm not going to give a new geometry lesson here, but that's the special relationship here. Now, why is this awesome? Because now check this out. If I said to you, what is cosine of 45 degrees? You would say, well, that is the adjacent side. Oh, real quick, it doesn't matter, but let's just say it's this 45 degrees. This is the adjacent side, A, divided by the hypotenuse, A radical 2. Now, this is cool because it doesn't matter what those A's are. They could both be 5, they could both be 7, they could both be 6, they could both be radical 15. I don't really care. They're going to reduce and make 1 over radical 2. Always. Now, what about sine? Sine of 45 degrees. Sine of 45 degrees is the opposite side, A, divided by the hypotenuse, a radical 2. And again, who cares what those a's are? 7, 5, 9, it doesn't matter. They're going to reduce, and you get 1 over the square root of 2. Now, this is even cooler because even if we were to look at this 45 degrees, it doesn't matter because the adjacent is A, the opposite is A, right? This is the only triangle when the opposite and the adjacent are both going to be the same. Now, I don't mind radicals and denominators, but some teachers do, some people do, so be careful. If you are told to get rid of the square root in the denominator, you're going to multiply the top and the bottom by radical 2, and you get radical 2 over 2. That is an equivalent answer. I really don't care personally, but maybe your teacher does. All right, let's do tangent real quick here as well, because this is even cooler. Tangent of 45 degrees is the opposite side A divided by the adjacent side A. And it doesn't matter which 45 degrees I'm talking about. The opposite is A, the adjacent is A, the adjacent is A, the opposite is A. And again, now it doesn't even matter what A is, because A divided by A is always going to be 1. So this is pretty cool, because this is a unique relationship that only happens when these 45, 45, 90 degree triangles. All right, let's look at the next special triangle. The next special triangle is a 30, 60, 90. And again, maybe you remember this from geometry, maybe you know, or you don't. But here's a 30, 60, 90 triangle, and the short leg across from the 30 is considered A. The hypotenuse is always twice A, and the longer leg is A radical 3. And again, if A is 5, then this is 10, and this is 5 radical 3. If A is 6, then this is 6, this is 12, this is 6 radical 3. Even if A is something weird like 0.7, then this would be 1.4, and this would be 0.7 times radical 3. You get my point, I hope. And again, this is a cool relationship that only exists in a 30, 60, 90. But what's super cool is that now if I try to find sine of 30 degrees, sine of 30 degrees is opposite A divided by hypotenuse 2A. Now, once again, it doesn't matter if A is 5, 6, 9, 1, 3, who cares? They're going to reduce, and you get 1/2. Always and forever. Now, real quick, why don't we just check this real quick on our calculator? I mean, I want you to believe me. Since I'm using degrees, I do need to make sure I'm in degree mode. And I'm going to do sine of 30 degrees. And check that out, 0.5, which you guys know is 1/2. All right, let's do cosine of 30 degrees. Cosine of 30 degrees. Again, is the adjacent side, A radical 3, divided by the hypotenuse, 2A. Who cares what the A's are? They're going to cancel. They're going to reduce. So we get radical 3 over 2. So cosine of 30 degrees is radical 3 over 2. Now, if you are going to use a calculator, when you type in cosine of 30 degrees, you're going to see a decimal. And you might try to convert it to a fraction, but it's not going to work. But that's because it's irrational. Anytime you got a square root involved, it's irrational. So if we do the square root of 3 divided by 2, you get that 0.866. You can confirm that you are correct. And let's do tangent now. So if we do tangent of 30 degrees, again, tangent is opposite A divided by hypotenuse, A radical 3. And I apologize, that A kind of looks like a 9, A. And again, it doesn't matter what A is. A could be anything. They're going to reduce, and you get 1 over radical 3. And for the third time, I think, in this video, I'm okay if you leave that square root in the denominator, but some teachers may ask you to get rid of it, multiply top and bottom by radical 3, and you would get radical 3 over 3. But again, that's going to always be true. So these are nice exact values. And I could also do the same thing with 60. So again, sine of 60 would be the opposite A radical 3 divided by the hypotenuse, and so forth. But these cool relationships only exist in these special triangles of a 45, 90 and a 30, 60, 90. So get used to seeing these angles, because these are great, famous, adorable, lovable angles. Now, let's talk about one more thing real quick. These are degrees, right? 45 degrees, 30 degrees, 60 degrees. Could give it in radians too. So let's make sure we know what these, because I want you to love these. I want you to be very, very familiar with these. When you see these degrees, you should be like super happy, because these are awesome. So let's make sure we recognize the radians as well. So let me convert them to radians. Remember, all I got to do is multiply by the conversion factor, pi over 180. Multiply by pi over 180. Remember, we want that 180 in the denominator. That way the degrees cancel, and we're left with radians as our measurement here. So 45 divided by 180 is, use your calculator if you need to, 1/4. So we get pi over 4 radians. So pi over 4 is equivalent to 45 degrees. 30 divided by 180 is 1/6. So 30 degrees is pi over 6 radians. and 60 divided by 180 is 1/3, so we get pi over 3 radians. So just highlight, star, write down these 6 values that are really just 3 values that are equivalents. These are important. You're going to see these. These are the 6 values that have exact, nice, beautiful answers. If I say, hey, what's sine of 23 degrees? 23 degrees is not 45, not 30, not 60. So sine of 23 degrees is going to be some irrational number that I'm going to have to use my calculator to get. There's no way you're going to be able to give me an exact answer. But sine of 45, sine of 30, sine of 60, you will. So let's quickly practice this, right? So notice that in these 4 problems, I see our angles that we love. Pi over 3, pi over 4, 60, 45. And again, hopefully you're slowly learning. Pi over 3 is 60 degrees, in case you didn't know. Pi over 4 is 45 degrees, in case you didn't know, but it's just converting. So these all have exact answers. You are more than welcome to type these into your calculator, but remember, your calculator might give it an irrational answer, but we should know, right? So look at your triangles. Draw your triangles. Make yourself a cheat sheet, and on that cheat sheet, draw the 2 famous triangles with 45 degrees and with the 30, 60, 90. Draw these triangles, and I know that I'm making very crappy drawings right now, but these triangles are super important because they make it so easy. So right now, pi over 3, which I recognize as 60 degrees. So again, looking right here at 60 degrees, cosine is the adjacent a divided by hypotenuse 2a. I know those a's are going to cancel out no matter what, so I get 1/2. There, I got 1/2. Like, I know it's exactly 1/2. I don't need any help to figure that out. Sine of 45 degrees. So here I'm looking at my 45-degree triangle, and I get opposite a over hypotenuse a radical 2. A's reduce 1 over radical 2. That's it. That's my answer, guys. I mean, I'm done. It's that easy. Even cotangent, all you got to remember is the relationship. Cotangent is the adjacent divided by the excuse me, I'm trying to go too fast here. Cotangent is the adjacent divided by the opposite. So again, here's 60 degrees. The adjacent is a. The opposite is a over a radical 3. A's reduce 1 over radical 3. I don't need a calculator when I have these beautiful, wonderful angles. There's 6 of them. Technically 3, just in degrees or in radians. Even cosecant. Remember, cosecant is the reciprocal of sine. So cosecant is hypotenuse over opposite. So if I'm looking at 45 degrees, the hypotenuse is a radical 2 over the opposite is a. A's reduced, I get radical 2. These are awesome. I can't emphasize that enough. You have to recognize these angles. You have to be prepared for them. These are the angles that we know exact answers to because these are the only 2 perfect exact triangles in the world. So when you see problems like these, pi over 7, what? 2 pi over 9, huh? 62 degrees, 25 degrees, you have no choice. The only choice is to pull out your calculator. Make sure you're in the correct mode. For the first 2, I need to be in radian mode. So I'm going to go to my radian mode here. Cosine of pi over 7. Don't forget to close that parenthesis. Boom, there's my answer. Sine of 2 pi over 9. Close the parenthesis. There we go. There's my answer. Now, I'm going to have to approximate those. 0.90096. Actually, that would round to 0.9010. Sine would be 0.6428. I can't give exact answers. I can't. The only ones you can give beautiful and nice exact answers for are the 3 angles, 30, 60, 45, or the radian equivalents that we saw. Now, for these next 2, I'm going to have to go into degree mode. So let me go ahead and put myself into degree mode. Or you could convert to radians if you wanted, but most kids are just going to switch modes. Now, notice that I do not have a cotangent button. So some kids will use, this is wrong, do not do this. Some kids will say, oh, well, above tangent, it says tangent inverse. I'm going to use tangent inverse because isn't cotangent the inverse of tangent? No, it's the reciprocal. So if you don't have a cotangent button, you would type 1 divided by tangent of 62. Because remember, cotangent is the reciprocal of tangent. So it's 1 divided by tangent. It's the reciprocal. The reciprocal of A is 1 over A. Come on. So there we go, 0.5317. Cosecant, that's the reciprocal of sine. There is no cosecant button. Don't use inverse sine. That's not what it is. Inverses and reciprocals are very, very different. So I'm going to do 1 divided by sine of 25 degrees. Close the parenthesis, Boom, there it is, 2.3662. So that's how you do ones if they're not the big three. The big three are 30, 60, 90, or in terms of radians, pi over 3, pi over 6, pi over 4. If you don't see those 3 or 6, you need to use your calculator. Otherwise, use those 2 famous triangles. Because I don't have a famous triangle for 62 degrees. I don't have a famous triangle for 25 degrees. All right, now, piggybacking off of all of this, right? Now that I hope by now, I'm hoping, right? It's a slow process. I hope you're slowly starting to truly understand the trig functions. Now, what can they help us do? One thing that can help us do is find missing values of a triangle. So notice here's a triangle. I gave you 2 pieces of information. 62 degrees angle, 45 feet is the adjacent side to it. Now, what if I said, find the hypotenuse? Okay, how do I find the hypotenuse? Well, the first thing is I have to utilize what I'm given. I'm given the adjacent side. I'm looking for the hypotenuse. What trig function utilizes the adjacent side and the hypotenuse? Cosine. So I'm going to set up a little equation because to solve, you need to create an equation. Cosine of 62 degrees equals the adjacent 45 divided by the hypotenuse h. And now I could solve, right? Cosine of 62 is a number. 62 is not one of my nice values, so I'm going to have to use a calculator, but it's just a number. So I'm going to multiply the h over to the other side to get rid of the division. And then I'm going to divide by the cosine of 62. Remember, cosine of 62 is just a number. So h is 45 divided by the cosine of 62 degrees. I could go to my calculator, make sure I'm in degree mode. I always make sure I'm in degree mode, or whatever mode I need to be in. And 45 divided by cosine of 62 degrees, close that parenthesis, is 95.852. So the hypotenuse is 95.852. Nice and simple. Let's try this next one here. All right, I'm given 48 degrees. I'm asked to find the opposite side, but I was given the adjacent side. What trig function uses opposite and adjacent? That would be our buddy tangent. So tangent of 48 degrees equals the opposite side x divided by the adjacent side 5. So now I got to solve for x, and I simply got to multiply both sides by 5. That'll cancel out the 5, and I will have x. So once again, I'm going to go to my calculator here. I'm going to type in 5 times tangent of 48, close that parenthesis, and there we go, 5.553. So x is 5.553. Awesome, easy. So make sure you understand how to do those very, very simple problems. All right, one more thing here, using trigonometric ratios to find them all. This is also extremely helpful. This is going to be something that we do multiple times throughout this entire unit. So make sure you really focus here. So let theta be an acute angle such that sine of theta equals 5/6. So the ratio of the opposite side divided by the hypotenuse is 5/6. Now, understand that that doesn't mean the opposite side is 5 and the hypotenuse is 6. I mean, that very well could be, but think about if it was 10 and 12. That would also be a ratio of 5/6. It would just be a reduced ratio. So the opposite side could be 10, the hypotenuse could be 12, or it could be 15 over 18, or it could be 20 over 24. So don't just automatically say, oh, the opposite is 5 and the hypotenuse is 6. Yes, that is certainly an option, definitely an option, but not necessarily what it's guaranteed to be because it could be a unreduced ratio. All right, now it wants me to find the other 5 trig functions. So I know sine, it wants me to find all the others. This is so easy. All you have to do is draw a picture, draw a picture, draw a picture. I do not care if your picture is accurately drawn, just draw a picture. Now, here's theta. What I know is that if I take the opposite and I divide it by the hypotenuse, I better get 5/6. Now, again, it could be 10/12, it could be 15/18, but again, reduced, it would be 5/6. Any of these would reduce to 5/6. Okay, so if I want to find cosine, the problem is I need this adjacent side. How do I find that adjacent side? Our old trusted friend, the Pythagorean theorem. So a squared plus 5 squared equals 6 squared. Always and forever, the hypotenuse goes by itself. A squared plus 25 equals 36. Subtract the 25 over. 36 minus 25 is 11. a squared equals 11, square root. So this missing side is the square root of 11. And unfortunately, that is an irreducible square root. So it can't be reduced. And if you want to try, you can, but 11's prime, so it can't. Sorry. All right, so now because I found that missing piece of information, I could find all the other trig functions. Cosine would be the adjacent divided by the hypotenuse. Tangent would be the opposite divided by the adjacent. Please remember, if your teacher wants you to rationalize the denominator, you would need to multiply the top and bottom by the radical 11. I am okay with it, but be careful if you need to. Let's see here. Cosecant is the reciprocal of sine, so that would be the opposite, or the hypotenuse 6 divided by the opposite 5. Secant is the reciprocal of cosine, so that would be the hypotenuse 6 divided by the adjacent radical 11. And cotangent would be the reciprocal of tangent, or it would be the adjacent divided by the opposite 5. Ugh. Nice and simple, right? And think about that. All I knew was the ratio is 5/6. And I was able to draw a triangle. Doesn't even have to be perfect. I'm not going to pull out a ruling stick and be like, I don't know, guys, if that's drawn correctly. I don't care. You just need it to draw a rough picture, find the missing side, and then start using your trig ratios. It really is that simple. I'm not trying to overcomplicate things. Let's end with one more problem. Here is a building. It is h feet tall. I want to know what h is. I'm giving you 65 is the angle of elevation. The angle of elevation is looking to the top of the building, and I'm telling you that that point is 340 feet from the base of the building. So once again, according to 65 degrees, 340 is the adjacent side. H is considered the opposite side. So what trig function uses adjacent and opposite? Our buddy tangent. Tangent of 65 degrees is the opposite h divided by the adjacent 340. It's really that unbelievably simple. Now, 65 degrees is not one of my special angles like 30, 60, or 45. So I unfortunately have to jump to the calculator, but the first thing I'm going to do is multiply both sides by 340, and that will cancel out the 340 and find h for me. So always, anytime I go to my calculator, make sure I'm in the right mode, in degree mode. So we have 340 times tangent of 65 degrees, and we get 729.132 feet. 729.123 feet. 729.123 feet tall. Don't ever forget units on a real world problem. All right, number one error I want to point out before we go is when you multiply by 340, don't multiply 65 by 340. 65 is the angle. Tangent itself. Tangent, that's a number. It's a number. You can use your calculator to find that number. You're taking tangent of 65 times 340. So please don't ever multiply the angle by 340. See, a lot of kids do that every now and then. All right, that's it for this video. It's a pretty long video, but a really, really important one when it comes to trigonometry. Enjoy.